Hello. Do you see that? Well, we have come to some strange times these days that we have to wear mask. But fortunately, since I'm recording in a studio and I'm all alone here, I have the luxury of removing my mask. Well, if I were to be in a classroom, unfortunately, unless I am about 10 feet away from the first row of students, I have to wear this for my own safety and more importantly, their safety. But fortunately, I'm doing video lessons, so hopefully you're all going to be safe even though I'm not wearing a mask. Will you be safe? Okay. My name is Mohana, Sosale Mohana. I have taught maths for a long time, around 50 years plus, and my strength is teaching of high-level maths, which perhaps I've done throughout my career, A-level maths and further maths. Of course, I'm not very good at stats. For the pure maths, for the mechanics, abstract algebra, those things are fine, but not statistics. I never learned statistics in my life. Anyway, let's continue from where we stopped. We were doing trigonometry in the last lesson. So I'll continue with topic 5. I think it's going to be quite a while before we move away from this particular topic because this is a very, very big topic and pretty exhaustive too. So many different concepts and formulae and ideas, but fortunately, ultimately you do single angles, definition, explanation, identities, equations, compound angles, definition, graphs if need be, then identity, equations, double angles, definition, proofs, identities, equations, half angles, pop, same thing. And then we come to transformations, how to find the transformation using compound angles, no proving identities there generally, solving equations. So, and later on we do radians, we finish a bit of geometry of circles, and then come back, same, equations, identities. Not identities, more equations. So, by the time I finish all this, it's going to take quite a while. Well, but all this is necessary before we think of doing anything further in calculus. So, therefore, today I want to talk of solutions. Yeah, before I do solutions, sorry, my apologies. I've given a handout for the last couple of lessons I have recorded on trigonometry. I talked about the ratios, I talked about the graphs, I talked about how sine and cos and tan vary, and I did some examples. But the one example which students struggle, the type of question students struggle, not all, some of you, is identities. And unfortunately, I couldn't do 40 identities. There is no guarantee there is a standard method for a 41st identity, even though you get general hints. I did about 3 questions. I haven't included any in my handout because I mentioned there the same thing. There is no single method. I remember way back in Kenya when we were doing a class test. That was somewhere in 1981, I think. Yeah. I'd given a question on identity in the mock exam. I was working nearly about 45 papers and I got nearly about 10 different methods of doing the same identity. So there is no way I'm able to exhaust all the methods. So I'll just do a couple more identities just to make you understand the thinking behind. I'll just do 2 more. I think I have only 2 more here. Let me take one of them. Prove the identity. Let's say number 1. 1 minus cos theta over sin theta equal to 1 over cosec theta plus cot theta. Both sides are equally bad. But then I can see here the right hand side is comparatively simplified when compared to the left. It looks like that. Let us see if I can work with this. If this is true, this is the case where I work and arrive at an identity. Can I write this as 1 over sine theta minus cos theta over sine theta equal to 1 over cosec theta plus cot theta. So what you can do to prove an identity, you can start with a question, fiddle around till you come across a standard identity. So this is cosec theta minus cot theta equal to 1 over cosec theta plus cot theta. Let's cross multiply. So it is cosec squared theta minus cot squared theta equal to 1. Please understand this is a minus b multiplied by a plus b is a squared minus b squared. So, and therefore cosec squared theta equal to 1 plus cot squared theta. And I say proved. Meaning, the logic mentally, even though you don't write it, what it means is, if this is true, that must be true. Deduction. If that is true, this must be true. If this is true, this must be true. If this is true, this must be true. I know this is true. So that's true, that's true, that's true. Therefore, the identity is proved. So that's the logic behind. So you can do it this way as well. Do I have any other identity? 1 minus cos squared theta over sec squared theta minus 1. Sine squared theta over tan squared theta is sec squared theta. Something like that. No, I want to use that later. Is there any other question I have here? I'm not too sure. Let me see. I made up or I looked up some questions from various my own experiences and other people's work and so on. Okay. 1 minus cos squared theta. Let me just take one more example. 1 minus cos squared theta. Sorry. Right. It's 1 minus cos squared theta over sec squared theta minus 1 equal to 1 minus sine squared theta. Oh, I haven't written the identities, right? Let me just write them here for your information. Sine squared theta plus cos squared theta equal to 1. Sec squared theta is 1 plus tan squared theta. Cosec squared theta equal to 1 plus cos squared theta. Cot squared theta. And then I have tan theta equal to sine theta over cos theta. And cot theta equal to cos theta over sine theta. Cot theta equal to cos theta over sine theta. Now look, this is what I would suggest you do on a piece of paper, or you have those memory cards where you make your notes. Put this formula, because every time then I'll spend more time as we go on, more time writing the formula than doing questions, so I may not write it. So if you want to watch any of the trigonometry videos, please have those ready, because I will quote orally, but I won't have the time to write down, because when we go to double angles and compound angles, I'll have another 10-12 formulae to write, so I'll spend up or I'll have to list everything and leave it there. I might do that, but I don't have enough space, then I won't have space to do the questions. So my advice to you would be, where possible, put it on a card and keep it with you, so when you attend the lesson, when I talk, you can look at the card to know what formula I'm dealing with. Yeah? Okay. Sorry, I know, I'm trying to help, but if I don't, please forgive me if I can't write everything. So that's the simplest form, right? So I'll start from here. What is 1 minus cos squared theta? The left hand side, or as my professor friend said, left side. 1 minus cos squared theta is sin squared theta over sec squared theta is 1 plus tan squared. So sec squared theta minus 1 is tan squared theta. So that is sin squared theta divided by sin squared theta over cos squared theta. In your year 7, you learned how to divide fractions. Flip and multiply. So that is sin squared theta times cos squared theta over sin squared theta. Pop, pop equal to cos squared theta. But cos squared theta can be written as 1 minus sin squared theta. Look, 1 minus cos squared or sin squared, then cos squared was 1 minus. So you use the formula this way and that way and that way and this way. So just giving you 2 more examples just for the sake of making you understand how to do identities. Now, I will go further. Identities, I don't need them now, so I may not use them now. I want to do some standard angles. You can use a calculator, but to remember a memory aid, you see the standard angles are 0, 30, 45, 60 and 90. And especially if the question has any of these angles, we expect the answers to be inserts or exact fractions. Alright? So you need to know these values. There are different types of, there's a particular MNE mnemonics or something like that somebody has written. Memory 8. So one way of remembering is I can have a right angle triangle that is 45 degrees. Look, that is 90, so automatically that will be 45. And these two sides are 1, that's root 2. So sin 45 is 1 over root 2, cos 45 is 1 over root 2, tan 45 is 1. And once you have those, you can find secant, cosecant, cot. So you can use that. Of course, don't worry, I will give you the handout later for that. 1 and root 2. Please, the handout will be literally a handwritten handout, because I can write this, but to put those values and put an angle, in fact, I'm waiting for my new tablet which converts handwriting to printed work or a PDF typed. Hopefully, if I can do that over this weekend, from next week, my notes will be a bit more presentable. That's what you use for 45 degrees. For 30 degrees and 60 degrees, this is what we use. That is 60, that is 30. How do I get that from? You have an equilateral triangle, right? Let's say of side 2. Then all sides are equal. If I drop a perpendicular, that is 1, that is 1. By Pythagoras, 2 squared minus 1 squared is root 3. I have bisected that angle, so that is 30, that is 60. That's where it comes from. So the height is root 3, 2. From there, cos 60 is half, and sin 60 is root 3 over 2, tan 60 is root 3. Sin 30 is half, cos 30 is root 3 over 2, tan 30 is 1 over root 3. Now remember, sin 60, is the same as sin of 90. Sin 60 is half. What is sin 30? Sin 30 can be written as sin of 90 minus 60. It's 90 times 1, so it becomes cos 60. Cos 60 is half, sin 30 is half. So that's the triangle we use. So that is 60, that is 30, that's 1, that's 2, that's root 3, that's 2, that is 1. You can use that triangle. The next one is going to be a bit difficult. you have to use, that's why the limiting case. Suppose I have a right angle triangle. Yeah. Suppose I have a right angle triangle. Let's say this angle is theta, A, B, C. Let's assume the hypotenuse is 1. What happens as theta increases? As theta, let's call this angle as alpha. So if theta increases, alpha decreases. If theta increases, alpha decreases. So what happens when theta becomes 90? Alpha becomes 0 and these two sides become 1. So we have an imaginary triangle. Such a triangle can never exist. The base angle is 90. That angle is 0. Opposite side is 1. Hypotenuse is 1. Adjacent side is, look, sine 90 is 1. Cos 90 is 0. Tan 90 is 1 over 0. When you divide by 0, it tends to infinity. Sine 0 is 0. Cos 0 is 1. Tan 0 is 0. But you can use a calculator. But that's again an imaginary triangle. So it's an imaginary triangle. It can never exist. It may not be mathematically sound to have this triangle, but it helps remember. So that's a right angle. That's 90. That is 0, 1, 1, 0. Such a triangle is impossible. But it helps get the ratios. But there's another way of remembering these things, which is, see, let's write the standard fractions. 0, quarter, half, 3/4, and 1. You remember the standard fractions? Yeah. Okay. Now take their roots. Take their roots. So when I take the roots, I get 0, a half, 1 over root 2, root 3 over 2, and 1. Yeah? Let's go back there. What is sine 0? 0. What is sine 30? Half. What is sine 45? 1 over root 2. What is sine 60? Root 3 over 2. What is sine 90? 1. Now, so these are the ratios for 30. What about 45? I mean sine. What about cos? Write the reverse. 1, 0, root 3 over 2, half, and 0. Oh, sorry, 1. Sorry, where am I? Root 3 over 2, 1 over root 2, half, and 0. Cos 0, 1. Cos 30, root 3 over 2. Cos 45, 1 over root 2. Cos 60, half. Cos 90, 0. To get tan. Tan 0, 0. Tan 30, 1 over root 3. Tan 45, 1. Tan 60, root 3. Tan 90 tends to infinity. So you can get the value that way as well. Let me see if I can put it in a more concise fashion. Yes. So remember, you find the roots of the standard fraction. So what I'll do is, I will put 30, 0, 30, 45, 60, and 90. This is angle. This is ratio. I'll put sine. I'll put cos. I'll put tan. 0. Remember, I'm using root of 0, root of half, quarter, root of half, root of 3/4, root of 1. The fraction 0, a half, 1 over root 2. When we work, I use root 2 over 2, root 3 over 2, and 1. Now write the reverse. 1, root 3 over 2, 1 over root 2, half, and 0. Now divide. 0, 1 over root 3, 1, root 3 tends to infinity. If you want to in the exam, of course these days you don't need it because of calculator. But when we were doing pre-university, that's equivalent to your A-level. To start with, we did this, but now even if you ask me in your dream, I'll be able to tell you. And most of the children in doing equivalent of A-level here in India either will use that or they will use this. I want to stop at this stage because next time I want to show you some methods of solving trigonometric equations directly or using identities. Okay? Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.